Now here is the question number 35. Sonu has N by 2 HCl solution and Monu has N by 10 HCl solution, and they are asked to prepare 2 liter of N by 5 HCl solution. It means both of them have HCl solution, they are just going to mix, and final normality of the solution is N by 5 and the volume is 2 liter. What volume of the two solutions be mixed? In this case, we will follow the normality equation. Let's solve this question. In this case, we will follow the equation N1V1 plus N2V2. We are mixing two solutions and finally the normality is N and the volume is V. In this case, the normality of the solution that was taken by Sonu was N by 2. So, I am just taking here N by 2 into. Let's assume its volume is X liter. Further, the normality of the solution taken by Monu is N by 10 and the total volume was 2 liter. It means the solution taken by Monu is 2 minus X liter, and that is equal to the normality of the final solution, that is N by 5, and the volume of the final solution is 2. We have this given equation. Let's solve this for the final value of X. If you solve this, you will find out the value of X is 0.5. And what is X? X is the volume, that's why it is 0.5 liter. And what about the volume taken by Monu? That is 2 minus 0.5. It is 1.5 liter. So, this was the volume taken by Sonu and this is the volume taken by Monu. And on the basis of this, we can find out the correct answer. The volume taken by both of them was given in option 1. So, the correct answer is option A. Now, let's move on to the next question, that's question number 36. Now, let's have a look on question number 36. A solution P was prepared by dissolving 6.3 gram of oxalic acid in 100 ml water. 25 ml of this solution was taken and was further diluted to 250 ml to prepare solution Q. What weight of NaOH in ppm will be required to neutralize 10 ml of solution Q? So, in this case, first we have solution P. Let's find out the molarity of solution P here. We're just going to solve this question, and first thing that we have here is solution P, and we just find out the molarity of this. In this case, we just have to check the amount of oxalic acid, that is 6.3 gram, and it is dissolved in 100 ml of water. So, in this case, the molarity would be 6.3 divided by the molar mass of oxalic acid. Moles we have now, divided by the volume also, that is 100 ml, and we have to change it in liter, and finally this is 0.5 m. This is the molarity of the solution P. Now, with the help of this solution, we have prepared another solution Q. Let's calculate the molarity of second solution with the help of molarity equation. M1V1 is equal to M2V2. This M1V1 is for the solution P. The molarity is 0.5. We have calculated it, and the volume that we have taken here is 25 ml. Now, with the help of this, we have prepared another solution Q. Molarity is M2 and it is multiplied by V2, and this V2 is 250 ml because we are just going to change this solution into 250 ml. So, this M2 would be equal to 0.05 molar. If you calculate it, you will find out this value. Now, what is done here? Further, this solution is taken, it is neutralized by NaOH, and after that you just have to find out the amount of NaOH which is required during the neutralization process. What would be the chemical reaction that will take place here? In this case, we have oxalic acid, it's reacting with NaOH, and during this reaction, salt is formed and water is formed. So, this is the reaction which is taking place. With the help of this, we can easily find out that the required amount of NaOH. In this case, the molarity of oxalic acid solution is given, that is 0.05 molar. With the help of this, we can find out the moles of oxalic acid present here, and we'll use this to find out the amount of NaOH. Let's check. The moles of oxalic acid, those would be molarity multiplied by the volume of the oxalic acid solution taken, but that should be in liter, that's why I'll divide it by 1000. So it would be 5 into 10 raised to the power minus 4. These are the moles of oxalic acid, and if you compare this with the amount of NaOH, with the help of the chemical reaction, we can easily find out that 1 mole of oxalic acid require 2 moles of NaOH. So definitely in this case, the moles of NaOH required would be 10 raised to the power minus 3 mole. And if these are the moles of NaOH required, then definitely mass of NaOH you can easily calculate, that would be equal to mole into the molar mass, that is 40 gram per mole. So I'll multiply here 40, and this would be 4 into 10 raised to the power minus 2 gram. And if you change it in ppm, 40 parts per million. And that is the answer that we require in this question. Let's find out the correct option. If you check the given option, you will find out that the correct answer is given in option C. So I'll just mark here the correct answer, that's option C. Now after this, it is the turn for the next question. Now question number 37 is here. Which of the following can improve the quality of petrol? We have different options given here, and we should know that if we talk about some additive to petrol, we have to compare its octane number. Higher the octane number of the fuel, better could be the quality of it. So definitely in this case, the correct answer is isooctane, which has more octane number. So I'll mark here D as the correct option. Now after this, it's a turn for next question.